Hello, everyone. Good morning.
Good morning, Sylvia.
Yeah, can you all hear me?
Yes, Sylvia, good morning. Yes, we can hear you.
Great. Fine. So let's start with today's session. So what we have covered yesterday, so all of you are able to find the notebooks and the respective files needed from your drive, right? Any issues in accessing the drive?
Yeah, we are able to access it.
Okay, great. So let's start with, let's start with the lazy evaluation approach, which is where we have left yesterday. So let me quickly bring in that sheet. So as such, the concept of lazy evaluation approach we have seen, which is basically used to make the efficient usage of your RAM space. So we discussed about that, and we saw that with an example as well on accessing a file which was not present. And it was not throwing any error. Rather, whenever we call an action-based API command, that is when it backtracks, it executes all the way up to the topmost command. And that is where it found out that the file is no more present, right? Or the file does not exist. So what basically is understanding here is only when an action command is hit, the execution begins. So if at all the execution needs backtracking to be done, that is when backtracking basically starts, right? So since it is not executing immediately after the statement is called, any transformation API commands, that's why the approach is basically called lazy evaluation, and it basically helps us make the efficient usage of the RAM space. Now, one more topic underneath this, which is your persistence. So let's talk about that. So one of the challenge in this DAG or in the lineage approaches, okay, I'm going to run a series of RDD one after the other. For example, something like this. So let's take initially you have your RDD1. And from there, I'm creating my RDD2, and then I'm calling the RDD2.collect. Now, this is how we did yesterday, and we have seen how it works. The moment the final action command is done, backtracking happens, and data has been collected. Once the data gets collected, the content of RDD1 and RDD2, which was residing right now in the RAM, gets automatically purged out. Right? Meaning we no more need those RDDs because the thing is the final output has been collected, and hence the earlier intermediate outputs are no more needed. So it will automatically be purged from your RAM space. Now, one important thing here to be noted on, especially in industry-based scenario, what happens is, I'll show a sample picture also. Yeah, see this one. So suppose imagine there is an RDD A, B, C, and finally I'm calculating a C dot collect. Now imagine this one single block is basically called as a module 1. We have 3 different projects running on our system. So the module 1 or the project 1 is basically involving A, B, C, and finally we are collecting the output. Now, okay, the process is done, output gets generated. A and B and C, all of them have been purged out or removed out from the memory, right? This concept till now we know. Now I'm going to run a module number 2, which is basically this entire step, right? So this green content, this green box is basically this is your module 2. Now, what do we mean by this module 2 is this is again another branch of RDDs which we want to execute. But if we go to the top of it, the very first RDD we need for this is again RDDA. Now I need to recalculate RDDA. Okay, suppose imagine what is there inside your A is basically like simply loading the file, splitting it, and extracting the index positions needed. Or if in case there is header is there, handling the header also is there. So imagine all these steps I'm doing under RDDA. So RDDA is a ready to consumable file. Now that A is going to be accessed for module 2 also and for module 3 also. So the thing is, there are 3 modules. For all the 3 modules, RDDA is a starting point. And that is basically like loading the file, handling the header indexes, header, and then splitting the data, and then extracting the indexes needed for us. Now the challenge is once the module 1 get completed, RDDA will basically be purged out from the RAM. So when I want to do the module 2 or module 3 and so on, basically what I'm doing is I'm completely recalculating the RDDA by again bringing the file into the RAM, doing the header job, doing the split, doing the indexes. Everything I'm basically doing because that entire module 1 is completed, the data has been erased out from the RAM. Now, instead of recalculating one more time, won't it be good if we find the RDDs in a module that are going to be reused? Right? Whatever module, whatever RDDs which I'm going to reuse, first go ahead and find it. And make them sit inside your RAM itself for a little longer period of time. That concept is called persistence. I know every RDD has to be cleared out from the RAM once its entire DAG is done. But if at all one or the two RDDs in that particular DAG needs to be reused, then I can identify them and I can call a function called persist, which will make them available inside the RAM itself for a little longer period. Even though that one single DAG is completed, but this RDD alone will be persisted in there. Now this concept is called persisting. Now why this is really useful? Because I'm unnecessarily recalculating that same RTD again and again if I haven't persisted. Right. So have a read on this. So when a data basically has to be persistent, when a data set is likely to be reused in iterative algorithms, where reusability is more. Right? The example that I said, extracting the file, cleansing it up, extracting the needed information. Now that is going to act as a base for all the different modules in your project, right? So what I can simply do is extract that result, persist it inside your R. Now, first tell me whether this concept of persistent is clear so far.
Can we go to that Databricks once?
Databricks, okay.
Where you have mentioned that collect function.
Mm-hmm.
Can you scroll above once? The time of, so in RDD 0, you have read the data, right?
Mm-hmm.
By default, it contains the data is contained in the RDD 0.
Mm-hmm.
And can you go back to that PPT once where you were showing the flow chart?
Mm-hmm.
So RDD A over here is the RDD 0 that we
Yeah,
saw.
it could be anything which is there, basically the starting point of your DAG. It could
Starting
be
point of.
A or 0, whatever it is. That is going to be the starting point. From there, you can do. See, in this picture, I'm saying this starting RDD is what I'm persisting. Not necessarily in all your projects that has to be the case. Right? Think of a scenario wherein you start processing, you reached a medieval point. That medieval point needs to be used as a starting point for an upcoming module. So it could be any RDD. Don't just think like only the very starting RDD always needs to be persisted. Depending upon your project, depending upon what you want to achieve, whatever position an RED is there and it is going to be reused, very well I can go ahead and reuse. Not necessarily it needs to be at the first.
So out of these here, I mean, there are 5 RDDs, right, in this flowchart. So out of these, it is not necessary that all of them should persist.
Is all of them getting reused?
Only one of them.
Then that alone you can persist. See, unnecessarily, if you keep on persist so much RDDs, what will happen? Think on that angle.
We'll lose the advantage of Spark.
Exactly. The RAM space has been overloaded, and I will not be even having enough space in the RAM to process any requirement going forward. So the thing is, whatever needs to be reused, persist that alone. Unnecessarily. So that is what the challenge that we need to address. The next thing. Okay, so now we got to know that the data needs to be persistent whenever there is a need for a reusability.
Sylvia, how long does it persist? Is there any time limit?
We'll come to that. We'll talk about that. See, the challenge is, imagine in a project wherein we are running hundreds of such DAG, right? Now, there definitely be a scenario wherein multiple RDDs getting reused. All of them are getting dumped inside. All of them are getting persisted inside the RAM space of your system. Now, don't you think at a particular point it will definitely reach the threshold? Right. So that's where Spark offers an approach called have your entire RAM space in which 30% of the memory I'm going to allocate, 30% of whatever RAM size you are having, I'm going to allocate for the persistent logic. And the remaining 70% is allocated for the execution purpose. So any DAG that comes to you, if you have a need for persisting one or the other RDD, you can persist it in the 30% of the memory for your RAM. So let's imagine it's going to be of 100G. 30G of your RAM space will be allocated for persistence, 70G for your execution. Now the next immediate question that can come is, okay, what if I exhausted that entire 30%? Right? Because over a point of time, that 30% will become very meager. And if you keep on persisting data inside your RAM, I will very soon consume that entire 30%. And going forward, any new persistent needs to be done. That again becomes a challenge. Right. Now that is where Spark is also offering you another approach, which is called least recently used. Or in short, we call this algorithm as LRU. Now, what is this least recently used? Very, very simple, very basic problem, very basic approach. What actually happens? See, all of this happens at the back end. You don't have to manually trigger anything in order to call an LRU, or you don't have to periodically go and check whether I have consumed the entire 30% or not. All of these will be taken care at the back end periodically. We are just trying to understand how the back end process is happening. Right? Now, what is this LRU? Simple. In this 30%, just imagine a scenario like this. I have persisted an RDD called RDD-A, which happened somewhere around 6 a.m. in the morning of today. Okay. Now there is another RDD, let's say D, which I have persisted around 9 a.m. I'm just taking a random number. It could be any time frame. Okay. Don't think, okay, there has to be a time difference of 3 hours or so. No, absolutely at any time we can persist. There is a RDE that gets persisted at around 10 a.m. Right? Like this, I keep on persisting one or the other RDDs inside my RAM space. Now what happens? Around 2 p.m. I'm running a code and that code needs to persist in another RDD, let's say S. But when it is when you're running the code for persistent, you are getting a warning saying, like I have consumed around 80% of this 30G, whatever 30% we do have, and we will not be having any more space available under the persistent section. Right? Now, before this warning comes to you, Now this, of course, you as a developer will be able to see. So there is a warning which states, okay, you're reaching the threshold point. Beyond this, if you keep on persisting, I will be completely, the complete persistent memory gets occupied, right? But remember one very important thing. Before this warning comes down to you, internally Spark applies this LRU principle. The key point here is before the warning comes to you, or after applying LRU, and even then a threshold reaches, that is when the warning comes. Now, what is this least recently used will do? Simple. It will go ahead and do a stat of, okay, what are all the persistent RDDs here? There is one which is sitting in the RAM from 6 a.m. in the morning. Imagine it is not even reused once from 6 a.m. till 2 p.m. till now. Right. There is another RDD, say RDD-D, which has been persisted 2 times from the time it is available in the RAM. Similarly, RDD-E, let's imagine it has been reused 3 times. So simple logic is, it will go ahead and perform a calculation, which one is sitting for a longer period of time and which is not being reused not even once. So such a RDD, it will forcefully delete from your RAM. I know the user has asked for persistent, but I'm reaching the threshold. So your Spark will forcefully delete that particular RDD under the concept of least recently used. Okay, but we will not be even having any idea on when an LRU is getting used unless and until you go and see the entire log file of your Spark cluster. We cannot even identify when this is happening. But whenever we reach the threshold, we should understand, okay, an LRU has already happened. And even after that, we are not having enough memory. That is why a warning comes down. So how I can avoid such kind of scenario, like as somebody said, can I go ahead and persist all the 5 RDDs? That is a mistake you should not do. So select the RDDs which you really want to persist. How you can select? Identify the RDDs which are going to be reused. As simple as that. Among the 100 RDDs you have created, not all 100 you are going to reuse. Maybe a max of 10 or 20. And in that 20, identify what are the ones which are really being useful so that you can go ahead and persist. Right? Now, another question. Somebody asked again, like, how long I can persist, right? Now, that is a customizable number. So, generally, it has been persisted from 6 to 12 hours, depending upon the availability of your memory, the storage of your cluster, and so on. But if you really have a very higher end cluster and your overall architecture support more than 12 hours also, very well I can go ahead and customize. But the default time frame would be 6 to 12 hours, anywhere between 6 to 12 hours, post which it gets automatically deleted from your RAM space. Okay. And along with this, Spark is also offering you one more approach of persistent. You can either go ahead and persist in the RAM, but if you feel no, I don't have enough space in the RAM, but I still want to persist this somewhere, then you can temporarily persist it in the hard disk of your systems. Right? So the calculated result, for example, after loading the file, clearing out the header, splitting it, extracting the needed index, I have a data. I would like to persist it. But I don't have enough memory available in the RAM space. And also, I don't want to recalculate it also one more time because again, the cost is going to be high. So what I can simply do, that calculated RDD, I can go ahead and persist it inside the hard disk because recomputation is much more expensive compared to the disk read option. Got it? So the choice is yours, the developer's choice. Depending upon the available memory, you can either go ahead and persist inside the RAM or persist inside the hard disk. And Spark offers you both the approaches. Okay, I'll do a complete recap on all of this. Please try to understand. So in a project, there can be n number of modules, and once one single module is completely done, that entire RDDs inside that particular module will be cleared out, which is a basic principle of your Spark. But the challenge over here is some or the other RDDs in that entire module or in that entire DAG may be needed for another module or another DAG. Now, instead of recalculating them again and again, the simple approach is to persist the ones which are needed to be reused. Now, how long I can persist them? 6 to 12 hours is default. You can increase or decrease depending upon the calling of that particular RD. What are the RDs that I can persist? Identify the ones which are really going to be reused and persist them. Where can I persist? You can either persist in the RAM, which is much more efficient and which is a default approach also. But if I'm exhausting, or if I feel like I will be exhausting it really soon, then I can go ahead and persist in the hard disk also. Now, whenever we talk about persistent, we should also be clear, not the entire RAM space we are allocating for persistent. Only 30% of the RAM space every node is taken for persistence. Now, within that 30%, I have to accommodate as much as possible. If not, you can shift it into the persistent in your hard disk. Now, before that threshold reaches, internally Spark also run an algorithm called LRU, or least recently used, which will identify the RDDs which are very, very least recently reused and purge them from the RAM, so that I'm getting enough space for the RAM for upcoming processes. Okay. Any questions? Is it clear?
So for the least reused algorithm, right, LRU, so Spark tracks the count of, so internally tracks the count of how many times it has been. So we cannot really see that, right? Like how many times.
See, all of this you can see, but then the challenge is they are not in a very readable format that anybody can go ahead, read it and understand. If you can see the log files which get generated in Unix, it needs little bit time for us to break it down and understand what is happening. For that matter, every single insert, delete, update, or a new addition of a file, or a persistent of a file, or the transformation, everything has been tracked down in the log file.
Okay.
But then the real challenge is breaking down the log and trying to understand. See, most of the time there will not be a need for us to do it. But then if we want to explore more about it, definitely we can do by breaking down the log.
Okay. And you said that 30%, 70% allocation, right? That can be changed also, correct? The ratio can be changed.
That is the default approach, and it is, I mean, there are ways that we can change it, but even if you go into the Spark's official documentation, they would highly recommend to stick with that 30-70, because that is a success rate of, I mean, that ratio was the ideally been used in a lot of successful Spark cluster projects. So what do they recommend is, don't change that, keep it as 30-70. Now, okay, this is a little advanced area, but since you asked this question, I can also tell you. See, this 30-70, 70 can be scaled out.
Okay.
Meaning, if in case I don't have a need for a lot of persistent, but I need more memory for new processing transactions. So some projects are like that. I don't have a need for a lot of reusability. Rather, new transactions I will always do. In that case, you can scale this up from 70% to even 80, 90, so that this portion gets reduced. This become 20 or 10 or so.
Sure. Yeah, understood.
Wherein the other way, right, that is not possible. This is not possible, meaning you are trying to persist something. You feel like, no, there is no, I mean, I need to persist much more. Can I increase this 30 by taking some memory from the processing side? Absolutely not possible.
Okay.
So the 70, the processing memory can be scaled out, but the persistent memory cannot be scaled out.
Understood. And one more question. With the architecture we discussed, right? The Spark driver is the master, and then it's going to execute. So when it comes to RDD, when we are loading or collecting, the same process runs in the background, right? Or the RDD itself is a completely. I mean, when we are going to actually run any program or anything against that, only then the driver will come into the picture, or even for the RDD operations, there is a Spark driver and other thing will be in the picture. I mean,
Driver will always be running. So there is no way like, okay, only when an RDD comes to process, let's trigger out the driver. Because your
okay,
Spark cluster will be up and running 24/7.
okay,
Because some or the other request will come and it go out. It's not like, okay, there is a program that right now comes from the client, let's trigger a Spark driver. No.
okay.
Spark driver will always be up and running. In your project, you will create an instance from the driver. That's it.
I
So the
see. Okay,
main driver will, the moment you start your cluster, the very first day when you start your cluster, on that day itself, your driver will run.
okay,
Every single project can take an instance from the driver. That's it.
understood. Yeah. And then even for the RDD, like even the slave nodes will be involved for. I mean,
Yeah.
all this follows, right? Okay,
Yes, all the slave nodes, wherever, I mean, see, for example, I'm running a project. That project needs to be applied on a file. That file carries 10 blocks. The 10 blocks are sitting inside 10 different data nodes. Then all those 10 data nodes will be involved.
understood. Yeah.
And parallelly, also, this is one more point which you have to understand, which is don't think that only these 10 slave systems are responsible for holding these 10 blocks alone. No, not necessarily. Inside one of the slave node, there might be 15 blocks, each belongs to 15 different files also,
Okay.
right? I remember this question asked by somebody in one of the batches, wherein, okay, when I say there is one slave node which is holding a block, don't think that slave node is only responsible for that block. We are talking about one single block because we're trying to understand the whole picture behind it. But internally, inside that slave node, it can carry some 100 blocks and they belong to 100 different files also. So that is where the
Understood.
cluster should always be up and running
Okay.
because not just for, it is not created only for running one single project. N number of requests can keep on coming.
Okay, Sylvia. It's clear. Thanks.
And one more thing here is don't worry too much about persistence because I mean, of course, in terms of interview, if you are getting a question, you should be able to understand. But then from the lab perspective, what we need to do is simply write the name of your RDD and call the function, say persist or cache. That's it. It gets persisted at the backend. Now, in your community edition, at any point of time, you can call a persist cache because this instance of community edition is created just for you. But also understand how it will happen in an industry-based project. Now, in an industry-based project, there is only one production cluster which will be up and running. And imagine, suppose there are 10 people working on that project, accessing that cluster. Randomly, if all these 10 guys started persisting, then that's not going to be the approach. Very soon we will exhaust the entire cluster memory, right? So it is not as easy as we are talking out here because in your industry scenario, if at all I need to persist something, it goes through multiple rounds of verification and multiple rounds of brainstorming. Because the moment I say I'm going to persistent, I'm going to definitely consume a good amount of RAM space. So how the organizations work over there is we will send it for different levels of approval. And once uh, after all this approval, if it gets the green signal, yeah, this already is really needed to be persisted, that is when this function will be called out. These functions cannot be called out from any random user ID because again, authentication will be controlled over there. So you will not be even having access to call these functions in your real case scenario.
So
Okay.
only admin can call this function?
I mean, I wouldn't say only the admin because we even developers do have, but then there are selective, I mean, you cannot do it from all the IDs that you're logging in.
Mhm.
Okay, I wouldn't call it as a job of an admin because a developer should also be aware on why we are doing it, when we are doing it, and all those. But then one thing you need to understand is it's not as simple or easy. Okay, I decide something to be persist, just go ahead and persist. No, that's not the way it works.
So, but if a user, so let's say that, I mean, at the front end, if a user wants to store the data, so at that time, does he have to reach out to developer or admin?
No, see, it's not like the requirement is going to come to you ad hoc. Okay, today I will be getting 100 GB file, keep on this file. So we will be having a framework approach created already now from the client. Okay, this is a processing that I'm going to do. So every Tuesday you will be getting a bunch of retail data which needs to be persisted because for the next 2 weeks we will be referring that. So you will be having that idea with you. I mean, whenever before you start working inside any project. So then what we will discuss, okay, so every Tuesday we can schedule a job such that whatever retail data that comes to me, could be a Parkway, could be an Avro, whatever data that comes to me, I need to persist it so that it can be used for the next 2 weeks or next 2 months or whatever time period that it needs. So that's how you will initially design. It's not like, okay, today you will be getting, let's go ahead and persist. That's not the case because the size is always huge, right? So accordingly, you can persist.
All these decisions are those taken at the time of developing the cluster, or it
Not
can?
at the time of developing the cluster, the time of kickstarting your project.
Okay. Can we
Okay.
see such options in Databricks as of now, or
Sorry,
not?
can you repeat?
Can we see such options in the Databricks cluster, that community edition?
Which option you want to see?
Uh, I mean, for data persistence that you are telling us.
See, there is no option as such. This is just like a command which you have to run. For example, see this. So
Okay.
I have this RDD1 here, right? Now let me run this. I'm having this RDD run. So now you will be having, if at all you want to persist this, you can go ahead and do a persist. That's it. But the internal logs will not be directly visible over here. So you have to, I mean, in your industry scenario, when you have a licensed edition of Databricks, the community edition will not be able to view here. You will also get to see the log happening behind it. Now there you can go ahead and see how much time it takes, in which partition of your RAM this is getting stored. So all those information you can identify. So this is the one you can do. There is nothing like a separate option that you can see.
Okay.
Okay.
Is there any way to track what are the persisted RDDs in the memory, like some listing out?
Yeah, we can do, but then again, not in a community edition. So there is a list of, so persisted list is there a command. So through which overall, what are all the persisted RDDs I can view. Also, with respect to every individual user, what are all the persisted RDs also I can do. So when I say user, when you log in, you will provide a credential, and through that credential only you will be running the commands. So at a user level also, I can get to see what are the RDs he or she has persisted. At a module level also, we can see. We can see very well, we can see, but some of
Okay.
the features are not available on the community edition.
Yeah, I got it.
But definitely we can view.
Sure. I think that will be helpful for the one who taking care of the cluster, right? So
Yeah.
to understand if the memory pressure is high, just to have a overview of what is being used. Yeah.
Yeah. So that will give an idea, and even sometimes it helps to track who has unnecessarily persisted an RDD also.
Yeah, exactly.
Yeah. Fine.
Sorry to interrupt, Sylvia. What is
Yeah,
DA?
yeah, go ahead.
You have referred to it a few times.
Sorry, what is DAG?
Yeah.
DAG is directed acyclic graph. We discussed about that yesterday, no? Directed
Where
acyclic
it is used, or what's the use of it?
graph. Hey, we discussed about that big time yesterday. You were not there yesterday?
I was very much there. I think I have skipped that part.
Oh, okay. It's a huge area, Pranjal. I would recommend you to watch the recording. I can give you a short description about it, but I may not be able to give you the complete thing that we have discussed yesterday.
Okay.
So DAG is basically like an lineage, the graph on which order you are executing the RDDs. So RDD 1 gets executed, from there 2 gets, from there 3. So when you understand the lazy evaluation approach, that is where we need to know the DAG has to be.
Okay, got it. So I missed I missed this term. Rest I covered that.
Yeah. In which case or scenario we will store the persistent data in the hard disk. Insha, simple. When you are getting the warning, right, saying like you don't have enough memory available in the RAM, likely you're going to touch the threshold. That is when I can shift it into. And not necessarily always you have to do. In some of the projects, what is the approach that they follow is I don't want to persist them in the RAM. I want it to be persisted, but not necessarily in the RAM because I have in a lesser RAM space. So I can go ahead and persist in the hard disk also. So sometimes it will be like an what say, like a knowing call I'll take. I know that I'm going to persist in the hard disk instead of RAM, but that is a call that I have taken consciously. So some projects even follow that approach because they don't want to unnecessarily eat up the RAM space. In some cases, once you get the warning, you can shift your persistent way to hard disk. Both can be deployed. See, all these are, it's not like a hard rule or a hard path. Okay, you have to go only in this approach. Depending upon the available memory of every single cluster and requirements pouring in, any of these options we can choose. Okay. Now let's get into a new component, which is Spark SQL. We haven't started this, no? Have we I guess we just discussed about what is Spark SQL, but we haven't started any.
Yeah, Spark SQL we haven't started.
Okay. Okay. So let's first understand what is this Spark SQL useful for, right? As we know, there are core SQL, streaming, and graphical application, graphics. Now, Spark SQL is mainly created for handling structured data, or you can also call them as named data. But then, what's the biggest advantage of Spark SQL over Spark Core? Spark Core has a lot of limitations when it comes to processing. We have seen that yesterday. You have to refer the index positions. There is no solid named data, right? Now, referring to that every single time by going, fetching a sample data, locating their indexes becomes really hard. And another important challenge is it can handle everything as text file only. It can handle everything as an array of strings only. Now, what if suppose I want to give a key value pair or a dictionary formatted file or like an embedded document file? No, Spark Core cannot handle, right? Imagine you're working for a client who is extensively using MongoDB for reading out their data, right? A simple example that I always say in my MongoDB classes, like you all know about Airbnb, right? Now, just imagine the backend server of how an Airbnb file will look like, right? What kind of data I need to capture? Not a structured SQL can help to store the data of an Airbnb server, right? Because what is the scenario here? Imagine there are some 100 resorts or 100 place accommodations are there. Now I need to maintain the data of all these 100 accommodations. But the challenge is one of the accommodation can have 100 features inside it, and another accommodation can have only 5 features inside it, and another can have 200 features inside. Now, I cannot make them strictly follow a tabular approach, then I will end up investing too much of memory, right? Because there is no solid structure maintained by all these 100 accommodations. And the challenge is some of these accommodations can add a feature, remove a feature at any point of time. I need to be dynamically available for that also. Now, such kind of data can be very well handled by NoSQL databases. And one of such example is MongoDB, right? Which stores them in the JSON format, which is like a key value pair. So for example, accommodation 1, okay? And inside the accommodation 1, so I can have different fields saying like number of people that they can accommodate and what are all the service. Do they have food? Do they have a cook available? Do they have laundry service available? And within that laundry, what is the rate, right? And what is the time? So all of this we can have. So dynamically, JSON files can handle all kind of data. So the traditional approach of SQL cannot help in storing data like this. That's where MongoDB comes in picture. And if a huge amount of data is sitting under your MongoDB and I want to process it through Spark cluster, then I will end up in going with Spark SQL. Definitely not in Core, because first of all, Core cannot handle JSON-based files. Right? So now, what are all the different types of files SQL can support? Now, that's a huge list. So I'll try to cover as much as we can. So we can have a JSON file, we can have a CSV file, we can have an embedded JSON or multi-line JSON. I believe you would have seen them in your MongoDB sessions. And pathway files, ORC files, simple text file, basic text files, DAT files, and sequential files. And data coming from any of the traditional RDBMS, Oracle or MySQL or PLSQL, whatever it is. Right? Now, and much more is there. So let's not talk about everything, but all these are quite important and some of the basic ones that you can see every day in and out. Now, since it offers a wide support for different file format, Spark SQL has an higher end compared to Spark Core. And the data abstraction over here is called data frame. This is also a very important advantage because this data frame you can very well relate with your pandas data frame, right? Which is also a named structure. Right? You have columns and you have values inside it. So what here we are going to do, we are going to create Spark data frames, right? By converting these files into a data frame based structure. Now let's see how we can handle this. So let's start reading one by one. So I'm going to first show you how to read a CSV file. So go to your file store. Any one of the file we can take. Okay. This file I have already shared you. So I'm taking this one. So observe this. So spark.read.csv and then specify the path here. Okay. Observe this carefully. I'm just writing df0 because I'm basically creating a data frame here. It's just like a naming convention. You can use ABC also or any meaningful name also. Now this is a simple API to read a CSV file. Spark, which is a default Spark configuration I'm calling. Read is an API within which CSV I'm specifying the path. Now, if I want to view the output of this entire file, I can simply call an API called show. Now, all of you know we have used something called collect, right, in our RDTs. And the same job of what collect has been doing here will be taken care by show. So this is to display the content. Let me run this. You can see how it works. Okay, let's see how it reads the data. So if I can see the data, there are some things that I can very clearly see, which is it reads everything in a tabular format, which makes my job little easy because understanding the data becomes simple, readable gets enhanced. Yeah, all these are good. But then I could find something weird wherein the header, right? The very first line of the file, instead of understanding that as a column name, it is consuming that as a data itself. Now, how I can tell my Spark that no, consider the very first line as a header? Simple, pass the parameter header equal to true. Now you run this. Now it has been automatically taken. The very first line becomes your header. Now one more thing, just observe. Can you see a drop down option here? Go ahead and click on it. Now it understands all this field name and it comes up with a data type also next to that. But something weird is even if it is a number or a numerical column, it is assuming that as a string, which I don't want, right? I mean, of course, I can do a typecasting at later point of time, but that's an additional headache for a developer, right? While reading itself, if I read it properly, I don't have to do the job of type conversion. So for that, there is one more property which you can use, which is called infer schema. Now, what do you mean by infer schema? As the name clearly says, read the value and infer the schema behind it, right? So pause these two and now you can see the data frame can be created perfectly. See, the duration becomes an integer now. Rating becomes a double now. Everything else becomes a string.
What was the last step? Sorry, I missed it.
Infer schema.
Infer schema. Okay.
So now show is a simple action-based API which helps me to view the content present inside this data frame. Now there is one more API also I will show you, which is called display. I'll just comment this and I'll show you. Now, what is the benefit of a display? Display will also do the same job. Display will also do the same job, like in a tabular form. But this is a little more readable compared to the show. See here, you yourself can understand. There are letters, numbers here, using which you can predict the data type. You can even arrange them ascending or descending here itself just to have a look. You can search for a particular value. Suppose 61 I want to know, then it can highlight that. Right? Some basic enhanced features you can find. You can filter the displayed data here itself without writing any query. So these extra features and advancement are there. I think there is visualization also. Yeah. You can visualize your data. You can select what can be on your x-axis. Suppose I want to have a channel name and then the rating. And you can, if at all you want, you can even do a group by on the rating and you can do. So all these features you can do and you can build out a graph here, right? See, these are optional features. You don't have to use them or in every Spark project, nobody's going to use it day in, day out. But just understand these features are also possible. Definitely not like your Tableau or Power BI. That kind of dashboard is different. But to an extent, I can get to understand and view, okay, how the data is being split. You can do a simple profiling here. Okay, so clear on CSV?
Sylvia, these features that you are explaining, this is only, I mean, Databricks specific or?
Show is by default available in all of your Spark clusters, not necessarily in Databricks.
Okay.
Even when I'm using it in AWS or anywhere else, if I create a if I create a data frame, I can use it. Display is specifically for Databricks.
Oh, okay. Understood. Yeah.
Okay.
And in the last concept also, you mentioned the persistent cache, right? So again, those two commands are same, right? There's no.
Those two commands are exactly same. Everywhere, wherever you go ahead and use, you do it in Azure, you can do it in a even on top of a Hadoop cluster. If I'm building a Spark cluster, there also it is the same. So these are what do they call the there is a nice name for it.
A proprietary feature or
The cosmetic functions.
oh, okay.
Yeah, so these functions, they call it as cosmetic functions because they don't do any processing as such. It helps you to view them in a different format. Some of these are specifically used for Databricks.
Okay. I mean, this doesn't come by default in the Spark library, right?
No.
They added as a feature in the Databricks.
Correct. Show is a default one. Collect, take, first, save
Yeah.
as text file. All those APIs that we have seen yesterday, all of them are used across. So this display is an extra feature that you can find here.
Understood. Yeah. Thank you.
Okay, and one more is also there, which is your print schema, which is also an universal function. Okay, I'll do one thing. Whenever there is something specific to Databricks, I'll tell you. If I'm not saying, then you can understand that can be universally used. That way we'll understand. Now there is something called print schema now, which is very, very useful in your real case projects, wherein you might end up in working on a huge data frame. You don't know what kind of schema it carry. Just simply call the function print schema. It will display out what are the different columns we have. Okay, and there is one more function which is, I'll show it here. df0 dot show of 10. So as you know, take of 10, it is similar to that. So only 10 rows it will try to display. Whatever number you are specifying, that many number of rows. So some basic functions. Now let's see how I can create a JSON files data frame. Again, simple. Instead of spark.read.csv, I'm going to write spark.read.json. So just a simple API. I will first locate a file. I'll share all these files, don't worry. Whatever I'm using in the class, I'll share on the drive. But if you want to work with something else, like from Kaggle or whatever websites that you have, or any random JSON files, you can very well use that also. Okay. Now I'm going to have this in a new data frame. And tell me, in a JSON file, do I need to add the parameter, say, header to true or infer schema to be true?
No, I don't think so.
Why so?
Because it's in key. So key is automatically header.
Exactly, right? Because a file format doesn't expect you to provide a column name. So there is no additional job of giving the header to be true or infer schemas to be true. So even if you could see the schema, it automatically predicts the schema. As well as if you come here and see the data, the column names have been properly aligned. Right? One important thing here, again, you will not find in everyday's file, but yeah. Sometimes what happens is the size of the data can be truncated when it gets displayed to you, right? Like here, it's something like short track speed skating or something, but then the last few letters have been trimmed out. Now I don't want that. I want to view the entire set. Then simply write truncate equal to false. So the truncate function will display all the truncated data also. So now see, now it will be showing you the entire data set. So this is for a simple JSON file, very straightforward, not of any complexities, because a simple JSON file is just like a key value pair, right? There is nothing new here needs to be done. Let's see on how I can create a complex or an embedded JSON. Have you guys used embedded JSON in MongoDB?
I think
Yes.
we haven't covered MongoDB yet in the
Oh,
module.
okay. Yeah. Oh, no worries then. I'll show the data you can understand. So what I mean by embedded JSON is nothing but, see, you guys know about JSON file. So JSON file is what? Like a key value pair. Like as I said, accommodation 1, the name of the accommodation, number of people that can be stayed, right? Like the rate, and then do we have a facility and all those. So if it is a single key value pair, then it is a very basic JSON file, right? Not of much complexities involved in it. But not all data will be as simple as we have seen here, right? The simple example, the Airbnb example, as I said, suppose imagine there is a key called name. Within that, I'm having the name of my accommodation. There is another key called services, right? Now within that, again, I will be having a key value pair. Now let's say a service, for example, like cuisine, right? What are all the different cuisines which are available under that particular accommodation? They are opting food as a service. So here again it becomes complex data because I'm not having one single cuisine. So probably in Indian, Asian, all these different types I can write. So I can keep them inside an array of values also. Got it. Now let's take another example. Give me some options. What comes on top of my what are the different things we can get in an accommodation? Okay, so let's see some recreation activities, right? Now, inside that, they have, let's imagine they have yoga, right? Now, that itself will again become an embedded file. So see here, so this is a topmost key value pair. Within that, again, I have an embedded key, which consists of an array also, and within which I can again have an embedded key value pair. Now this list can keep on go. When the data becomes really complex, the list can really becomes huge. And this is how most of your NoSQL data will look like. They'll not be straightforward key value pair, right? Now handling these kind of data really becomes difficult. And more than just storing, extracting them becomes even more hard, right? Because suppose I just want to know the yoga, the accommodations which are offering yoga specifically from morning 6 to 8. I might be having 100 accommodations. Filtering them based on this becomes certainly a challenge because it's not like straightforward filtering. So such kind of files, how we can load, let's see. So for example, like I can write spark dot read dot option. Okay, so understand this carefully. What is an option? Here I have to pass a parameter called multi-line true and then call the JSON, and then within that you can provide the file. Okay, now if I go ahead and view it, you can see how it looks. Multi-line.
Syntax of the
No, it is, no, this is right only. This is options, I guess. Let's see. Yeah, so my bad. It has to be options because in the read out options, we can have a lot of parameters. So it is basically an options. Okay, so now again, some of the data get truncated. I will pass a false. So this is just a sample JSON file I have created just to show you how an embedded data will look like. Now see this. So city, there is one single value. Okay, country is also one single value. But when it comes to location, it has basically three values. Can you see? Three values. And these three values are enclosed inside an array, correct? And they have been stored inside a dictionary like a key value pair. So this is going to be my key and this is going to be my value. In the key, it is an array of value. Now similarly, this is a single key value pair. Now again come to students. Now in students, it's a dictionary, right? Now I'm having a key value pair again, which means I think this is university data, no? So this is number of students who has passed on this so and so year of passing. So this is again a key value pair, but it is not a single key value pair, a list of key value pairs, so enclosed inside array format. So such complex data can be converted easily into a data frame with the help of your read options. Got it? Data need not be always straightforward. It can be like this approach also. Embedded JSON is different from BSON, Mahesh. BSON means binary format of JSON. Even a plain JSON file will also be converted into a BSON. I mean, I don't want to go deeper because you guys haven't started your MongoDB sessions. No, during the time you will understand. So to give you a very high level view, BSON means binary format of a JSON, which will be created either for a like a file like this, a single key value pair, or it can be generated for an embedded file also. Why we need to generate it? Because MongoDB converts a JSON file into a BSON and then stores it inside the server. It is not like the entire data will be stored in a JSON format itself. It will convert the JSON into a BSON and stores. For multiple reasons, it supports huge data types. It supports reduction in the size of the memory, so on and so forth. Got it, Magesh? Don't think BSON as an embedded JSON. They're completely different types. Clear here? JSON and embedded JSON. Now let's head into one of the most important file format, which is Parkway files. Probably.
I have a question.
Yeah, go ahead.
So is it possible to convert the embedded JSON file to binary JSON file here? Is it possible?
Every JSON
Like to
file,
split?
when you are trying to store in MongoDB, will be converted into a BSON file.
No, in the notebook here in this Databricks.
No. See, BSON we are talking about is for MongoDB, not for data, not for Spark. So the question that he asked was, embedded JSON is it same as BSON? So I explained him, no, they are not the same. BSON, you will not find it here. Here it will be stored as a normal JSON file only. But then in MongoDB, that is specifically created for handling complex JSON, right? Everything is a JSON format at the back. So that is where you can find. Here I cannot show you, or we cannot convert it and view that.
Just like what we have here, this data we have here, this data now. Is it possible to convert it? Maybe I can extract location, our name and student, then the embedded file, I can split it and get another data frame from me. That's what I'm asking. Is it possible over here?
From this data frame, extracting only the needed information and creating another data frame.
Yeah, just the embedded, like what you have US, you have 247, the number of students that passed and the date. So is it possible to create a data frame out of that? So you now have only single binary JSON.
Very well, we can do. So it is just like, again, applying filter conditions on any normal data frame, right? So what you are saying here is specifically, for example, let's take, I want to extract only the number of students passed on the year 2014 to 16. Something like that.
No, that's not what I'm saying. What
Hmm.
I'm saying is, this is an embedded JSON file. We have you have under USAL, you have numbers of students, different numbers of that is, I can create out of this, I can create number of students and dates from this. That's what I'm asking. Is it possible?
Yeah,
Instead of having the embedded.
See, but then the reason for why do you think the data has been embedded here? See, I can simply create a students column instead of having a student column and having the embedded value. I can have two columns. One is having the number of students, one is having the years, right?
Okay.
No, I'm asking you. See, instead of
Yes.
having the value like this, I can very well have it in a tabular format like number of students and passing year. And I can have it, no? Now, why I need to create such embedded format? What do you think? Same way here also. I can have this as my latitude value. I can have it as my longitude value, some other coordinate. And then I can have it as a separate. See, the reason why it comes down to you, because in the source it gets generated in an in an unstructured embedded format. That is how the data comes, because it cannot be enclosed inside one single structured format. That's the reason the data comes in this manner. So first, is that part clear why it comes to you in this manner?
Yes, it's clear.
Okay. Now coming to your question on uh, can I convert this embedded format into a normal format, right?
Yes.
No, is that what you're asking?
Yes, is the question.
Ah,
Converting embedded to binary,
no.
normal JSON format.
Yes. But then the challenge in converting the embedded into a normal format is if I start having the embedded data into a normal data, obviously the size of the data becomes really huge. And it again, you are bringing back all the disadvantages of having a structured file.
Okay, all right.
Right? Because structured data has certain disadvantage. It needs to have values for every single column that you have to maintain. That is where I moved on into an unstructured format. Now, when I again bring them back, again, I'm accepting all those disadvantages.
Okay, thank you.
Fine. Now, let's talk about Parkway files, which is quite important. As I said earlier also, Parkway files are something which we use a lot in big database projects. Now, what do you mean by Parkway file format? First thing, it is a columnar file format. Now, what I mean by a columnar file? See, generally, these are some of the very common interview questions, guys. So let's try to understand. So generally, if I'm keeping a data in a file like this, or forget about a tabular data, just a notepad, a text file, okay? Whenever I have a data like this, and if I want to process this, the data will always be processed row by row, right? It will take one row. Suppose I'm writing where location is equal to Bangalore. It will take every row, identify whether the location column is equal to Bangalore, then it returns that record, right? So it basically goes record by record when it comes to processing any of the data inside a table or inside a file. But what Parkway file format is suggesting is, it's not even going to store the data in a row format. Rather, it is going to store everything in a column format. So column 1, column 2, column 3, column 4. So it will store it like this. Column 1, all the column 1's data will be available here. Column 2, column 3. So suppose I'm
Just
asking
like
you first,
JSON, right?
just like this. So suppose I'm getting a question like I'm asking a query where location is equal to Bangalore. I don't even have to go to all the rows. Rather, go to the location column. Imagine this is a location column. Just check the values inside. Identify wherever Bangalore is there. Then their respective values from the second and the third columns it will take and give you. Now, this will save me a lot of time compared to the traditional row file format method. That is one of the biggest reason big data always try to keep their input files in a packway file. Right? And all these columns are embedded at the back, which makes the storage also much efficient. So that is one of the biggest advantage. Now, another advantage of Parkway is it has embedded metadata inside it. So what I mean by an embedded metadata, see, this is one sample I'm showing in your notepad here. Can you find some symbols? Not everything is readable format now. So these boxes, I don't know what do they mean, right? But at the end of the file, I could find something like name, favorite color, type, string, null, name again, favorite numbers type. So what is this basically? This is nothing but the metadata. What are the data types of every single column I can find? So what does a Parkway file do? Every single Parkway file's metadata, which is the field name and the respective data type, they get embedded along with the actual file itself. Now, suppose imagine you are working with some CSV, right? Now, your client has to separately send a file called metadata because CSV cannot have the metadata embedded inside. I have to always pair it up with the metadata, right? Wherein unlike in other file formats, Parkway comes with an embedded metadata, which makes the conversion really simple and easy. And also, I don't have to separately look out for a metadata file. Every single Parkway file comes along with an metadata information of the file. And the third is, it is also encrypted. Now, there are a lot of compression techniques that it use, gzip, snappy, and so on. But irrespective of whatever file format it chooses, it is always in the encrypted part. Right? That's why it's not in a human readable format. Got it? Now, these are the advantages why big data platform uses Parkway files a lot compared to CSVs or JSON. JSON files to an extent has been used. And if you can observe, the Parkway files will start with the letter PAR and end with the letter PAR. One just refers to the version of it. Okay. Now let's see how I'm going to load this. First.
So metadata means we can say that is a structure, right? Structure of data.
Metadata is a schema. Like what is a column name? What is a data type of that file?
Fine, fine, okay. So mainly we are using only Parquet in big data.
Yeah.
Okay.
I mean, not that the other formats are not used. Majorly, this will be used.
Okay.
Sylvia, one point is not clear. You said when we are getting CSV file from the client for processing or whatever, we also get the metadata, right? I didn't get the point because the CSV itself as the what you can say the type of column or whatever, right? The schema can be understandable, right? So why we need a separate metadata for that?
Okay. See, the thing is, some of your CSV file will come with this header information inside it. Like the example that in your YouTube you are seeing, the very first line is your header line.
Okay.
Right? But apart from that, do you know about the data type of rating, data type of comments? No. But then I can infer the schema to understand, okay, this is a number, so I'm going to consider this as a double column, or this is an integer, so I'm going to consider that as an integer column. Now just think on this scenario, like What if this is a string column, but right now I'm getting all numbers inside it? How do your CSV will infer it? As of now, today you are getting in that column, it is all about just numbers you are receiving.
Right.
But there is a possibility that it can handle strings also. But what your CSV will right now do, it will just see the value so far and understand, convert it into an integer. But the client or the customer who has forwarded that file to you, they will know, no, as of now it's numbers, but strings will come up on the way. So this
Okay.
can only be understandable when I see the metadata information.
I see. Got it. Yeah.
Right? This is one example I'm saying. There can be lot of such scenario wherein just by seeing the value alone, I cannot predict its data.
Okay.
Another simple example could be date. Right? So like this, there are a lot of examples wherein just by reading out the data alone, metadata cannot be always be right.
I see. Okay. So it can be a detailed description of what each column refers to, right? Something like
It will be like this. You can see here. So this is one sample metadata embedded inside a Parquet. So it will be like this. This is one single column's metadata, which is the name of the column is favorite color. The
Okay.
type of the column is string and it can accept null value inside it.
Understood.
Now,
Okay.
similarly, if you can see favorite numbers is another, see this. So this is a little embedded data, which means it is an array data type.
Okay.
And within the array, we are having integer.
Yeah.
Right. So these level of info is called basically metadata.
Understood.
I have a question.
Mhm.
We need to always open this metadata file, like Paraquet file, to look into the metadata.
No, you don't have to even view it. In fact, I should not be even viewing it in this format because they should not be opened in Notepad. There is
Okay.
a separate Packway file reader through which only we can open. In fact, you don't have to even open it. See, what your Spark is doing out for you, when you're calling the spark.read.packway,
Mhm.
internally that is what Spark is doing out for you. It goes to the file, understands the metadata,
Yeah.
pair the metadata with your file. I'll show this here. See. And it will display the data in a proper readable format for you. See this. This is the actual data.
Yeah.
I could not understand anything like this by reading it here.
Yeah.
Now you don't have a need to open it and view. I'm just trying to show you so that you can understand how it will actually look like.
Yeah. Just one question here. So we are
Mhm.
able to see the values, right? Like what are the names and favorite colors. But if you want to know, like what is the data type of, okay, fine, got it.
This is always comes to you in handy. You will be finding this drop down option.
Mhm.
You can do this. But this is only in Databricks again. Now you do not have a drop down option like this in other platform. That is where you need to use a print schema function. This one.
Okay, got it.
In Databricks, it's little simple, comes handy.
How the Parquet file is encoded?
There are different compression techniques. By default, I think it uses gzip. I don't exactly remember. I guess it is gzip, which is a default support of uh, Parquet. But then with the licensed Parquet files, I can even change this to any other compression technique that I want. This is by default. When you open the file itself, it will be in a compressed format. Okay, you don't have to worry on how this compression technique works at the back. So that is not our job. Our job is mainly to convert them into a readable format the way that we need.
Can I know actually embedded means embedded format, right? Actually, default embedded option is there, no? In Parquet. What is that actually?
You're talking about JSON or Parquet?
Parquet.
In Parquet, see, embedded is different,
Okay.
encryption is different, right?
Okay.
I'm talking about encryption techniques here.
Okay.
Embedded comes into picture when I'm trying to embed different types of data into one single data type. That is embedded. Encryption
Okay.
is you are not able to read it just through your human eyes.
Okay. So okay, fine, got it. So what is maximum size of parquet? Do we have any limit for that?
I'm not so sure. I think, but I have seen used up to TBs also. But
Okay.
if you ask me, is there any upper limit? I'm not exactly sure. But
Okay,
up
fine.
to TBs also, we do have pathway files.
Okay. A CSV actually, CSV is there, no? Like CSV, we
Mm.
have some options.
In
Actually, this is my.
CSV, there are only two options max because CSVs are not much flexible like Parkway. It follows a raw file format approach.
Hmm.
Max is only these two. Or to an extent, you can change the delimiter,
Okay.
something from comma
Got
to
it. Got it.
something.
Got it. Actually, I have small doubt here. Okay.
Mm.
I missed few classes. Okay. But actually, normally when we are inserting data from Parquet to a database,
Mm-hmm.
okay, is right time to ask this? I think we have
Yeah, yeah,
some.
yeah.
Fine.
Go ahead, go ahead.
Like actually, when we are inserting huge data, like we can say Parquet data, huge data. Okay,
Mm.
we can say that Parquet normally in database, first insert in database, we can say 100 GB. Okay,
Mm.
or 150 GB, we can say. That one actually I processed to Parquet actually. Okay, I kept it in Parquet.
Mm-hmm.
Okay, then I process the data. After
Mm.
that, what I did actually, again I need to insert the data. After process, no, I need to insert the data to database.
Mm-hmm.
Okay, but while doing it, actually they are asking to keep the data in from Parquet. I need to create one CSV or text file. Okay,
Mm.
then
Mm.
again they're asking to insert the data to
Correct,
database
correct.
because actually they have some default option not to insert the load in file or something, right? In
No,
database.
because the plugin will not support Parkway into DBMS.
Yeah.
Yeah.
Some loading issue we are facing. I
Mm-mm.
tried it actually. So we should do like this only, or we have some other option also.
No, unless and until you have a driver which will convert that Parkway into a CSV which can be loaded, we can do it
Okay.
in that way. But
Okay.
see, again, the driver is doing the same job what you are doing. You are
Hmm.
manually converting that Parkway into a CSV and loading that CSV into an RDBMS because
Yeah.
RDBMS don't have a direct plugin to read Parkway. It cannot understand what is Parkway.
Hmm.
The input file can either be a CSV or a text file.
Okay.
We do have some drivers available. You can check it on some of these jar file libraries are available in sites, no? So you can check out
Okay.
for a Parkway to a CSV file converter.
Okay.
So you can download that jar file and you can run that jar file with your Parkway as an input, which will give you the CSV as an output. That you
Okay.
can load it into a DBMS. But then this is the only option. Either you do it manually or with the help
Okay.
of a driver, you can do.
Got it. But this is only way. First use
Yeah,
way.
yeah.
But
Yeah.
actually in here only I got doubt.
Mm.
Actually Parquet I am keeping like this 150 GB also very less only we can say size. That data I am creating in CSV. That's okay. And I am after CSV I am uploading to this one
Mm.
database. Okay.
Mm. Mm.
But problem no actually in case that is in TB
Mm. Mm.
that SQL CSV will support. That's my
Mm.
question.
But then why you want to again convert it into a CSV?
Actually, we need to keep it in the RDBMS database. That
See,
after
so,
process, no
okay.
processing we are doing in here only. No, Parquet
Mm.
only we are doing right.
Mm.
Data
Mm.
frame. Yeah.
See, the simple thing is traditional RDBMS cannot handle a huge load. That is the main reason we are coming to platform like big data. That's the first
Mm,
thing, right?
mm,
Because
mm.
they have limitation when it comes to size, they have limitation when it comes to type of data they are dealing with. That's where we are moving into platforms like big data. But
Mm.
then again, if we want to load them back, we should be aware of the fact that RDBMS cannot handle certain loads. That's the reason I
Correct.
moved it into big data. Now
Mm.
again, what's it? I'm doing the ulta, the reverse case. No, again
Got it.
process the huge result. What's the point in taking into again an RDBMS?
Correct. Okay. Got it.
So we need to think a little bit more over there, but then I can understand because this issue is there in some of the projects too, wherein
Correct.
the clients will expect the data to sit only in the RDBMS, but at the
Okay.
same time, they have a huge amount of data which it can
Correct.
handle. So that is where I can offer you one more solution, wherein these cloud services, right, like AWS or Azure, they do offer RDBMS which can scale, right? So
Yeah, yeah.
probably you can tell to your clients, like, I can still maintain a RDBMS based structure, but not on the traditional ones, rather the ones that cloud services are offering.
Got it. Sure.
Okay.
Okay.
So this is a Parkway file format. And what's the next one? Maybe I'll show the SQL data.
Sylvia, I have one doubt. So can you scroll above once? So in this DF2, I mean, right now, it has been transformed into a data frame. So on top of it, there should be multiple rows for name Elisa, right? Because the
And
numbers
multiple rows for Alisa.
because in the column favorite numbers, the value is in the form of a list.
Okay.
So ideally, a cell should contain a single value, right?
Not necessarily in your data frames. So that's where we are coming to data frames. In your traditional systems, that's not the case. If I'm talking about in RDBMS, every single column has to be atomic, right? That's what you're saying. So a single column means it has to be one. If at all I need to maintain, then I need to transpose. So what I'll do, I'll have Alicia null 3, Alicia null 9, Alicia null
Yeah,
15.
that's what I meant by multiple.
That is a old way of doing it. That's a traditional way of doing it. Don't you think that incurs too much of memory?
But
Right?
if
For
I want
5
to,
values, I'll end up in creating 5 different rows. So now to avoid all of that is what we are creating data frame, because data frame accept these types of data very well.
it's okay in terms of data frame, but if I have to do analysis on it and store this data in a data warehouse, not only in the RDBMS, let's say Google BigQuery or AWS Redshift, then in that case it will be required, right, to explore this data frame.
No, I wouldn't suggest doing that way, because it's again similar to the question asked by the previous person. Sorry, I don't remember the name. So it's same like that again. See, I'm having huge data set. I'm trying to make my job simple by adopting a technique which cannot consume lot of memory. But again, I'm reverting back into that same old technology which is going to consume more space. Means, that's not ideal, is what I guess. You need to keep them in a platform which supports these complex data, minimizes the memory, process it well out here. If at all there is a need to again move it into the RDBMS, you should be aware that the size is limited.
Okay.
Got it?
But how can I perform data analysis on top of this data?
This can very well, we are going to do. So just hold on to it. It might look like it is having series of information, how I can read it, how I can process it, but that's where the efficiency of Spark comes in.
Okay.
Right. So let me create a seek file data. This is basically given by the user itself. Not in lot of projects we will find this. But certainly you can find this in during the time of debugging, or you want to adopt a new logic on your existing production code. You want to do a sample check. So for those reasons, we can create this. Yeah. So some name. So I'm just generating a tuple of values, okay? 2 tuples inside an array. So some column names is equal to something like customer number, customer name, and amount, some fields. Now see this. So df, what is the last number? 3 equal to spark dot create data frame is a new API. Now what does it offer? So far what we did, we have the data coming in any of the file format. We have a specific reader for that through which we can convert it. But what if I want to manually check my code with a sample of like an ad hoc data, right? That is when you can use this create data frame function. It accepts two parameters. One is data, another is schema. So now if I do a df3.show, what it will do, it will try to read this data, use this schema, and then converts it into a sample data frame like this. So not used a lot, but then these create data frame API comes handy if you want to quickly check something. Right? You will find this really useful, especially in scenarios wherein your production code goes for a toss. There is some bug, some unseen situation happening. You want to just do a random check on why and what is happening. So that's where the SQL data can be of help. So use a create data frame API to convert any data into a data frame. Okay. And here there is just a second. So here there is one challenge, like as we discussed earlier. Now, how the schema is basically predicted just by seeing the name. Just by seeing the value. Like as somebody asked earlier. Now, what if the data comes different? Or initially it might come as an integer, but then I might get some string also there. So what my infer schema will do, it will just now predict it as an integer only. Okay, and here, if you wonder why it is long and not integer, the Spark's default data type for numbers over here is long. That's why it is basically a long data type, right? You can convert it into integer if you want at later point. But yeah, coming back to that question on can I supply the metadata information also? I know I've supplied the data, I supplied the field name, but I haven't supplied the data types inside this, right? Also the nullability inside this. Now we can do that also with the help of another function called struct. Let's first see this and then probably I'll take the questions. So I'm just going to call a library for this. Okay, I don't remember the exact library name, so I'm importing everything. So sample schema, right? Struct type is the function within which you have to pass different fields will carry the same struct field. So there is struct field within which I'll pass C number, which is it stands for the customer number, and then what kind of data type it is going to hold. Integer type. Okay, so this is for one column. So for the second column, string type. Integer itself, because the numbers are really smaller here, so I'm taking, or you can take it as a double or a long also. Okay, simple. That's it. Close a bracket, run it. Now, after this, I can create a new data frame, df4, new schema df3. So some name I'm writing to understand it. So again, I'm creating spark.create data frame. I will supply data to be, what is the name? Data, sample data. But schema is going to be this sample schema and not just the column names. See, earlier what we did, we only provided the column names. I want Spark to understand the schema behind it by inferring it. But right now, I will give you everything. I'll give you the field names. I'll give you the data type also. You just create according to however I asked. So now see the difference. Data is going to be same. There's no difference in the actual value, but then the data types can be modified. So all of your, like most of your projects, especially when we are building sequence file, it is always good to come up with a struct, so that it will be uniformity. Uniformity will also be seen across the projects wherever we are using the sequence file. Clear? Any question?
So it's used for just changing the data type. There's no difference in the final data frame type, right?
There is a difference. No, this is, if you are inferring, it is going to be the default one, which is long. But then I can change it to an integer. While reading it itself, it will accept it as an integer. It will not, it is not like loading it as a long and then converting it to integer. While reading itself, it understands that this has to be of integer.
Yeah, that's what I asked. So basically, both will create the data frames. It is just that the schema will be different.
Because you're passing a different one. See, both are not the same. That's what I'm trying to tell you. So this is not, this and this are not the same. Here you're only passing the columns. Schemas are inferred. Here you are passing the columns and the data types. There is no inferring here. You are specifically saying this has to be. And this is not as type conversion. This is again a common question that can be asked. So people mistakenly think this is type conversion. No, this is not type conversion. Type conversion will be done with the help of cast function. Type conversion means there is an existing data type which is there, which is, let's say, integer or string, and records are there. The file is already loaded. For some of your processing, you want to convert the type from integer to string or string to integer, whatever the case be. That is called type conversion. I'll show you that also. So for that again, so going forward, we will use this PySpark SQL functions a lot. So I would recommend import it at the first, so that you will you don't have to unnecessarily solve some errors. Right. Let me show you how to do a type conversion. For example, like I am having a C number. Now while loading it, I loaded it as an integer, but I kind of realized going forward there can be strings also. So I would like to change the data type of that one single column. Now observe this. So this is my data. Now the very first API that you're going to learn here would be select, which is very synonym to the select statement that you write on your SQL. Okay. So I'm just writing select. And one important thing here is, in your DF, whenever I'm calling any columns, it should be enclosed inside the keyword COL. Because I don't want my Spark compiler to get confused with keywords and the field names. So I have to explicitly specify the word column, within which inside your double quotes, you can specify the. So in this case, I have the column. I would like to cast it to string type. Right? So now what happens? It is selecting only the column C number, right? Which is an integer. I would like to change its data type into a string. And this is like a new call C number. So if you could see the data type, it's been changed to string. Values is exactly same because right now everything is number. So no issues. So you're selecting the column, converting it into a data type that you. So remember few steps here. Select is just like selecting the columns. Call within bracket, specifying the column name. Column name should be specified. Now, there is the latest version of Spark. Right now we are in 3.x is what right now we are in. One of the latest feature of Spark, latest version of Spark is without the field name, without the keyword call also it will work, right? But then some of the functions, so we are going to see aggregate, we are going to see group by. No, those functions still demands the columns to be enclosed inside COL. So what I will do in all of my session is have it as an universal practice. Within any keyword, if you are referring a column, use the COL. Even in your industry-based projects also, you will find this as a like a pattern, because we don't want things to be confused between column names and the keyword, right? But then without COL also, just specifying them inside brackets, will consider that as a column name only for selective keywords, not for all the keywords. Probably I can see this like this. So select, within that you have to again write df dot that column. Now wouldn't be a good option. So rather you can write like this itself. Data frame name dot and then the call function. Okay. How to give column? Ram Srinivas, here there will be a third parameter that you can pass as, after integer type, you can pass it as true or false. True will accept the null value, false will not accept the null. Got it, Ram Srinivas, and everybody else also will just see this.
Whether the date field, okay, will accept zeros.
Whether the, which field?
Date field, date and time is there. Okay, it will accept zeros, like instead of null. Okay, I'm having 000 in data.
You have to give it in the date format. If you have created that column as a date for date data type, no, then
Okay.
even if you are trying to provide zeros, it has to be like this. Because the format is YYYYMMDD.
MMD, yeah.
So rather than that, I would prefer to set it as a nullable column.
Null.
So you can pass a null there.
Right, actually, I'm getting some error in that. Okay, that's all.
Okay. If at all you want to view this only in this, see, sometimes clients know I don't want to see any null, rather coalesce it with something else. There is a function called coalesce. You might have seen in SQL statements. So you can just pass coalesce, or if null also is there. When date is null, replace that null value with whatever you are specifying.
Okay.
But then a single zero will not accept because the data type is date.
Got it.
Fine. So, yeah, one thing here, if you guys are not having any doubt in this part, tell me one thing. See, suppose I'm trying to change the data type of this particular column, okay? And I am not storing it. Okay, see, right now I have taken only one column and I changed the data type and I'm creating a new data frame out of it. Now, suppose I'm asking you, no, let's make this change on the existing data frame itself. Then how will you do?
So in case that is a string, actually in string, okay, we need to give int function like Python, okay, dot int we can give.
No, my question is different. What I'm asking is, see, right now this is your source data frame, right? Now, if I even show the, see, if I do a print schema, the C number is still an integer there, right? It is not converted. It is not type converted. Why? Because I am reading the data frame, I am doing a type conversion and I am storing it in a newer data frame, not on that same data frame, right? Have you guys learned about in place function?
In place. Right.
In
Okay, yeah.
place equal to true.
Exactly. That is what I'm trying to say. So in your pandas data frame, you might see this in place equal to true. So what that one will do?
So in same data frame, we can change the data type.
Exactly, right? So here though there is no in place function as such, but a similar to in place that you want to do, just copy this and put it here. That's it. So you are reassigning the value to the original data frame itself so that it gets replaced on the existing data. Okay, these are some simple things, but we need to be aware on all this, right? So there is no function as such called.
You need to put the DF4 new schema, DF3, right, in the left side.
Correct. It's like reassigning it.
Right.
Okay, fine. Again, like how we did yesterday, I'll start explaining some new APIs now because we have finished how we can load different type of files into a data frame. Now the next job is how I'm going to process these data frames, whatever data frames that through different methods that we have created. So how we can learn all the APIs is there are quite a bunch of APIs. Whatever I feel like it's going to be really useful for you in your career, all of them I'll cover. But let's not discuss them separately. Rather, let's do a use case so that we learn the use case also and we will learn the keyword also parallelly. Fine. So I'm going to take a file, any random data frame, you can pick it up through different methods that we have used. So for example, I'm going to take this YouTube one. So spark.read.csv, it here itself. I'm good with the data frame. Now, the very first thing that we're going to learn, how to select some of the columns. Select some columns from existing data frames. So my existing data frame was YouTube 1. So I'm just writing like use case 1, wherein I would like to view only certain columns. Let's say probably I'll need the video ID. Okay. And then I would need number of views and number of comments. So how many views it has got and how many comments it has got. So when I show that, it will give me only those columns, whatever I'm asking for. Like how we did in RDD, instead of storing it in a new data frame, I can directly write a show also here. But when you're directly writing a show on top of that, that's not going to be stored in any new data frame. Rather, if you want the result to be in a new data frame, always store it in a new one, and then we can get to see it. Okay, so this is simple, very basic one, selecting one column or n number of columns, as many number of columns. If suppose you want to view everything, you can even write a star also. Right. But now next one would be how to filter out the columns. Okay. Now again, the same simple filter API is going to come here. So I'm going to write my YouTube dot filter, simple. But then remember, I'm going to specify a column. So use a call keyword. What is a condition that I'll write? Probably I want to know all the records where the number of comments is greater than 1000. First, will I have one condition, then I'll show you one more. So just simply write number of comments is more than 1000. And I would like to view that. Okay, simple. So how is the syntax? Straightforward, filter, specify the field name, the logical operator greater than, and then the value. Simple. This is for a single condition. Now see all the records, all of them are greater than 1000. Great. Now I'm going to apply for two conditions also. Now here, there is one thing that you need to understand when it comes to Spark operations. See, suppose I'm writing, I want the number of views also to be greater than 500. Okay. So what I'm writing is condition number 1, right? And, which is the AND operator. The ampersand is the AND operator here. And then the condition number 2. Okay, I'll just run this. Just see there is an error that we'll get. This is what I want you guys to understand. Please understand this is something which is unique to Spark. We generally see there is no mistakes in this. So especially for beginners, it might look really confusing. There is absolutely no syntax error. I have closed all the brackets. So now why it is throwing an error? And the error says clearly the method and the integer does not exist. So what do they really mean here is, so this is how the Spark compiler works. Now, whenever a condition I'm basically writing like this, yeah. So whenever I write a condition like this, the ampersand symbol will straightly connect the immediate prior and the next value. For example, in this case, it is trying to compare 1000 with this. That's why it is showing you the integer cannot come here. Because what is the logic of an ampersand here is right before this whatever value here, right after this whatever value here, it will consider that. So in this case, it is considering column number of views and 1000. It cannot understand what do we mean beyond that, right? Now to us, of course, this syntax looks sense, but then the compiler cannot understand it. Now to make it understand clearly, what you need to do whenever you are adding more than one condition, try to enclose every single such condition inside a bracket. So what it will understand now, okay, universally you are enclosing this entire stuff inside this one bracket. So it means this whole condition has to be considered as one. And hence this whole condition has to be considered as one. So the generic syntax ideally would be, whenever you are writing more than one condition, it will be like condition 1 and condition 2 whole should be enclosed inside your filter operation. Now, without a bracket, don't try to combine conditions. Then you will end up in getting that error. Okay. See, now it is proper, right? Just with some small change, I got the code working. Okay. So the number of comments is also greater than 1000 and the views are also greater than 500. So I am getting certain number of rows here which satisfy my condition. Fine. Now, I don't have null as such here, but I'll also show you if in case you have null, how you can filter it out. Simple again, just go ahead and call this filter. On which column you want to do a null check, right? For example, I'm having here duration to be checked. So I'm writing duration dot is null, simple, basic function. And if in case there is any null in that particular column, then give me the records. So can you see there is nothing? Because as of now, in this particular data, I don't have, or I could not find any null value coming up in the column. Just understand the isNull function is basically to identify the null in any column, right? Specifically, you're mentioning a column and you want to know whether that column is having null in it or. One more thing. So I'm going to check category. Okay, let's say category. So I'm going to check category belongs to any of the following values. So we call this in Python as a membership operator, right? Is or in or is in. So that is what coming up here also. So I'm going to check if it carries any of these categories. Go ahead and provide. So news and politics, right? And finally, show it. So give me all the rows where the category column belongs to any one of these three values. That's it. Comedy, news and politics. What is the other one? Sports. Okay. If at all it is there, all of them will come to here you as an output. So this is only showing the top 20 rows. So you might miss some of the records here. You can do a show of 100 or show of 1000. So that many rows will basically come down. Okay, simple filtering operation, quite basic, very similar to the var class that you can use in your SQL classes. It's quite simpler and same as that. Okay. So now comes something which is really interesting, which is adding a new column to the existing DF. Now, we know there are certain columns which are already present. For example, in this case, I do have video ID, channel name, so and so. Now your customer is asking, along with this entire data, I also want to know one more column. Let's call it as popularity. And how this has to be, if at all the rating is greater than, let's say 5 is max, no? So probably if at all the rating is greater than 3.5, call it as popular. If it is greater than 2 and less than or equal to 3.5, then call it as probably average or probably likable. Okay. If it is less than or equal to 2, then call it as probably average. Right. Now, can you guys relate this with anything in your SQL? I hope all of you have completed your SQL module, no?
Case when then?
Simple case when. Whatever we can do in your case when, that is what now we are going to do. Now, even in case when, you will build a new column based on the values of the existing column. So the same thing is what I'm going to do here as well. Let's see how we can do. The API is only going to be different here. So YouTube and then with column. Now with column is the API here. Yeah, one thing I'm not sure whether you guys have observed so far or not. If you could see in all the APIs that we are learning, whether in Code, Spark, or even here in your data frame, all these APIs supports camel case. Have you observed, guys? All APIs support camel case. Right? In general, in Python, we do have this concept of camel case. No? So the same way in your API also, all of these APIs will have this camel case logic. Or in more than one word, the first letter of the second word will always be in upper letter. Now, which column I'm going to create? I can create any. So, for example, I'm going to call it as popularity of the video. Something like this, I'm writing. Now, let's see the syntax behind it. When is a keyword here we have to use? Again, quite similar to the SQL statement. Now, what are the conditions? When the column rating is greater than 3.5, then call those videos as popular. Right? This is one condition. So connect it with the dot. Now I'm just writing in the next line just to make this thing little readable, but you can definitely write it in one single line also. Now again, when the rating is greater than 2 and rating is less than or equal to 3.5, right? Then go ahead as likable. So remember that AND logic. So I have to enclose these stuffs inside a bracket separately. So I'm opening a bracket here and I'm closing that bracket also here and I'm ending this here. Okay, so this is a second condition. Now third, now here you have two options. Either again you can write a when clause saying less than or equal to 2, or you can simply write otherwise also. Which is quite similar to the if conditions, the nested if conditions, or the if else statements. So when you use the otherwise, it is basically nothing but if else statements. So obviously if it is an otherwise, I don't have to specify any condition, right? I can just simply write average videos or not likable or however you call. Okay, now I'm going to store this in a new data frame and I would like to view the result. So what we are getting here is based on the rating that I have got, right? The popularity has been changed. So 2.2.3, just likable, 0, average, 3.67, popular. So like this, I can create any new column and the value of that new column can be created based on the values of the existing columns. Is it clear? The with column feature? Very, very useful one in many cases. I will also show you without the otherwise as well. Because sometimes you don't have to use the otherwise. Rather, I can again write the condition. True, then it is average. Okay. One thing, there is a possibility that you might miss something which can lead to an error is the brackets, right? Otherwise, the statements are pretty simple. So whenever you are writing with column, and especially which involves a lot of when conditions, just try to make sure you're having a proper alignment on the brackets. Got it? Okay, so this is creating a new column based on the values present in the existing column. Now the logic can be up to you. It could be like anything. It could be like an arithmetic operations involved or a logical that you can see here. So depending upon what is our use case, I can go ahead and build. Now also on the other hand, I can create a new column just with a function also. Okay, so I am creating a new column called now or time or anything of that sort. And I'm calling either a current date or a current timestamp. Okay. Now, suppose you have a requirement where you need to capture the stat. So for that, every record, whenever they get inserted, you need to know the timestamp behind it, right? Then you can have the with column function to create the timestamp also. Okay, don't do both of this together. Just write to the next slide. And if you feel like some of the records are truncated, you know how to handle it. So clear guys, so far any questions in the with column? So this code also please observe. You able to understand the syntax?
Yes.
See, the syntax might look little bit different for you right now, but then with practice, these stuffs become simple and easy. Yeah. Now let's get into okay, one more thing you can learn. Yeah, here it is. Storing a default value in a column. Now this is not advisable, but what I have observed is in some of the projects, we do have these kind of columns being inserted also. So good to know kind of stuff. So what I'm going to build, again, YouTube. I'm going to create a new column, but this time the new column is going to hold a literal value inside. When I say literal value, it means that constant value that's going to be stored inside. So I'm going to create a column called in country, and it is going to hold only India inside it. No other values. Now, very rare situations, you might end up in something like this. But for reporting purpose, at times what I could see is projects demand to have such column. Now, generally, what do we say is there is no point in having this column itself because that's going to be universally holding the same value. But in some cases, like as I said, while generating your BI reports, these columns are needed. So for that reason, we might have a column like this. So if I want to keep a constant value, use the keyword LIT. LIT stands here for literal. Okay. Now, if you are just trying to do this initially and you're getting an error saying cannot identify a function or no function called lit or no function called when you are writing these statements, it simply mean you haven't called this library. Okay, I told you a library, no? What is that? Yeah. This library is needed before you start working with your with column or your with column renamed or any of these stuff. Just remember to call this library. Otherwise, you will get the error saying undefined functions or stuff. Errors of that sort. Fine. So now I created a column. I know how to hold a value inside the column, either a constant or a value or a function generated value. Yes. Now I would like to change the name of a particular column, right? Any column you can pick. Okay. And I wish to change the name of the column. Again, here in place equal to true comes in place. Either you can update it on the existing data frame, or you can change it and create a new data frame also. Now, please learn about both, because in your industry projects, you will sometimes do both scenario. Now you are creating a new copy of the data set that's going to be used by another module. In that case, you will build a new data frame. You want to make changes on the existing data frame, then you have to be just aware. All the people who are accessing this file should be aware about this change in the name. Got it? So just remember that part. So how to change the name of a column? Simple. With column renamed is a function. Now the APIs are pretty self-explanatory. They're quite basic words. There is nothing complex that you need to remember or stuff. So for example, like what is a column we have? Okay, we have category, right? Instead of category, probably I'll say genres. Okay, that's it. So the old column name, comma the new column. Now see this. Now if I simply write a show here, this will be reflecting in my output, correct? But this is not going to be reflected in the original data. See here, in my original data frame, it is still category, because I read that column and I'm changing it from category to genre here. So in this temporary result set, there is a change. Okay, now I don't want this to be temporarily changed. Rather, give me like store it in a new column. Sorry, new data frame. So D of 9. And then D of 9 dot show. This will make the change and show it inside your show open bracket close. Then it will give you the updated column. Basic stuff. Okay. Right. So this
Please
is
scroll back to scroll to your then last yeah.
this one.
No, this when you were shaking the schema. So you use a YouTube. So if you check the schema again, will it show that now with the YouTube dot original data?
I am not doing it on the original one. No, I'm generating a new one. I'll show how you can make change on the original one also. See, you have to just use the same data frame. See, now you see the schema. Now it has been changed. So you are reassigning it into the original data frame, wherein here you are calculating, but you are storing them in a new data frame. Is that clear?
Okay.
This is what you were asking, no?
You know, you need to assign it to the original data frame. It just because you use the YouTube to explain, so I was thinking it has something to do with the change. So that's why I was asking. So
Yeah.
now that you do it, will it automatically change on the YouTube or just asking? Because you mentioned it earlier in the previous after changing to the category column name. You use YouTube to say, okay, it was not showing, it did not change here. And then you now went to the second one, assign it to the F9. So that's why I was asking.
Okay. See, the logic is pretty same as your pandas data frame. If in case you guys have covered pandas data frame and you make any changes, at the end you will call in place equal to true. So there is nothing called reassigning. Rather, we have the function called in place equal to true, which means any change that you are making gets reflected on the source data frame itself. Rather, we don't have such kind of functions as such here. Rather, we have to reassign it into the original name. I guess you guys are aware on the memory address concept inside Python, right? Mutability and immutability. Yes, no,
Yes.
right? Same principle applies here also. So because when I'm trying to reassign, don't think this is the original data is actually getting modified. Contrary to that, in Python, how things basically happen. See, for example, this is my original YouTube data frame content. Now it will reside in a memory address, let's say 1001. Okay. And all the content inside it are inside 1001. They have a name called YouTube. Now, the moment I'm reassigning it, it does not mean the changes are reflected on this memory address 1001. The changes are there in some other memory address. Probably it could be 2001. Just that the name is pointing to here, the earlier pointer will basically be removed. So the 1001's data is still present, but your YouTube is no more pointing to that. Rather, your YouTube is pointing to the new memory address. Same as a memory address concept on your integer, string, list, sets, dictionaries, all of that in Python. Okay. That's why they are immutable, but yet you can change the value. But we are not overwriting on the same place. Rather, we are creating a new memory address. Fine. So now let's move ahead. So far, is it clear, guys? Any questions on what we have seen so far? Any of these functions? Okay. Now let's see how I can change the name of a column, but it's not going to be for the existing column, rather for a newly generated column. Now we call this as an alias, right? Now in your SQL statement, you will have a keyword called as. So for example, you can write select max of amount as max underscore amount, or select average sales as average. So what does as keyword will do? It basically generates a new column out of that function. Now, now that same thing can be used in your PySpark also. So for example, I'm writing so I'm taking the category column, and also I'm going to take few functions inside it on top of some basic string functions. Okay, length of category. Now here you have to call a function called alias. Now what that alias function will basically do, to the immediate function, whatever is the output that you are getting, that will be named as such like this. So it gives a name as length of channel name. Oh, sorry, not channel, category. Okay, so now I'm going to do a show. That will give me the result. It's wrong. So column or function parameter cannot be resolved. Do you mean any of the... Oh, I have changed the name from category to genres, right? So no more category exists. So only genres. Okay, that error was basically because I changed the name from category to genre, but I was still referring that as category. So it throws an error saying, I could not understand what you mean. So I now changed the name and now it is good. So what happens? First, I initially take the genre column and then I'm trying to find the length of it. Now, if in case I'm not creating an alias, how it will look, that also I'll show you. See, I'm not going to put an alias initially. Just close the select statement. Just run this. See, this is how the output will look like, which will not be ideal when you are generating reports, right? So now for that reason, we generally go with some alias names. So just instead of the as keyword, you will be writing the alias. Now same way for any function that you are building, suppose writing channel name, and then I'm going to write concat. You guys know, right? A simple concat function of both the columns. So column 1, comma, column of channel name, close the bracket, alias. Both will come together. You can have a truncate to be false also. Right? So this is your genre, this is your channel name, they both get combined. Like scenarios like first name, last name being combined, or the different products that they have purchased that needs to be combined. So any of those logic you can use concat. Now, sometimes what happens when we do a concat, I wouldn't generally recommend using just the concat function because, I mean, you can combine as many columns as you want, but not with a concat because the challenge here is when you combine them, there is no split between them to understand what is what, right? So to know that, you can use concat underscore WS. Now, what that concat underscore WS stands for? Anybody know? This is there in your Python itself, no? With string, that's it, right? So you have to specify what is that string-based column which I can use to concat. It could be some series of asterisks or hyphen or a comma or could be anything. Not with space, Insha, it is string. Now that string can be a space also, but then the meaning over here it is for a string. It can either be a space or it can be a string. So see here, now I did a space between both of them. Now it is much more readable compared to the earlier time. Right? Now I can also have a star here, an asterisk here. So that will also help. Have a look on all of this. Take a minute. Tell me if you have any doubt.
So one main difference is in SQL query, like we, as a general syntax, we have update, insert, record, anything like that, right? But here with the keyword select, it can be used for the update modification of operations also, right? That's what it is.
Update as such, you can do it with the help of with column for creating something, and for select. See, this I will not call it as an update. This is basically generating something new is what you can do it with a select. Now
Okay.
for transactions, we have separate bunch of comments. So this is all about either generating a new column or combining few columns and again generating one more fresh column here, or checking their nullability, replacing the nullability. That is what we have seen so far. Now, you can do an update. I'm not denying the fact that you cannot do an update, but then think little bit logically here in terms of big data. Now, as we have discussed yesterday, big data is not meant for transactional purposes, right? Meaning you get an 100 GB of data. You will not be updating every row on that 100 GB every single day. That is mainly an historical data. Now, update mainly happens to frequent transactional based data, which will not come under the concept of big data. Because when the moment when I'm saying it's a huge amount of data, it's going to be a collective data, a historical data in place. Now, you can perform updates, but that's not going to happen very often like in your transactional database system, like in your RDBMs.
Right. Yep.
Okay, perfect. Fine. So now let's do one more. Any other questions, guys? Seems everybody gets exhausted. No questions on the way.
One last question, maybe like, can we also log the data frame not to be modified, anything like that? Is there any possibility? Just in case to protect the data, if the developer thinks that way.
There is no such thing as locked, but what we can actually do is we can block the privileges of all these operations on a specific data frame.
Okay.
Like you have TCL commands in RDBMS, right? Like grant, revoke,
Yes.
providing the privileges or blocking the privileges. So through which I can control, okay, so and so user or so and so users who belong to this particular group cannot touch upon this particular table. They can read the table, they can view the table, but they are not allowed to either generate a new column or update an existing record.
Okay.
Okay.
Thank you.
So those are quite similar to TCL, transactional control keywords, but at a without an user, just as in data frame level, you cannot control. With the help of the groups and users, you can control.
Got it, Sylvia. Thank you.
Okay. So one more thing we'll see. We'll see about sorting the data. So, again, I'm heading back to my not sort by. It is just a sort. I'm calling the rating function. So sort of column of rating. Just to show first we'll see, and then I'll show you. So this is in the ascending order, right? Because we are not specifying anything extra here. So by default, it's going to be in the ascending. Now, obviously, there will be a question on how I can do descending. So simple. Ascending equal to false will do that job. So what we will get is the descending order. If you guys remember in the yesterday session on your RDD, we have used an API called sort by, wherein we pass a parameter, just say false. So just a false over there will make your Spark understand. I'm looking forward for a descending order. The same as such here, but I would be explicitly specifying it. Now, okay, some of you might have observed this. When you keep your keyword when you keep your cursor on a particular API, you will be getting a suggestion window like this. I would also recommend you, if you find this is of helpful to you, please go ahead and see this. But then the reason I generally don't go with this always is, this will be with a very simple data that they will do. And the challenge is, these are old version syntax. So that will not be periodically updated with the latest syntax, latest versions syntax. But then if you are getting stuck, if you are not able to proceed with the syntax, or you need to have a textual description, you can just scroll this. They will give you an example also. So if you see here, this is another way of doing it, which is sort. You have to pass ASC of age. So this is what I said. This is in the old version. But as per the latest one, you can just simply write call of age itself will do the job. And you don't have to again write the data frame name one more time. Just a call itself will do the job. These are different alternatives that you can choose. Choice is yours. So I have seen some of the developers still using this approach of data frame name dot sort. Instead of writing call every time, they'll again write the data frame name dot column name. Now, which is still acceptable. I'm not saying this is wrong, but then it becomes really challenging when your data frame name is quite big. Don't you think so? See, suppose you're generating something like premium customers or premium video list or something like that, then you will end up in writing that again. So here DF is nothing but the name of the data frame. If in case it's short, it's great, but then the more bigger it is, and also I could see readability is not great in this version of writing the syntax. So this will be having an uniformity across. Choice is yours at any day. Fine. Now, one more thing also we'll see when it comes to sorting, which is I'm going to sort it based on more than one column. Okay. So, which is like, I'm going to sort it based on the rating. As well as the view score. Now tell me how this one will work when we do it like this.
First, first it will sort with ratings and then with a number of views.
Okay, but then when the preference will go to the number of views?
Second.
Which means when the rating is duplicated, then the preference will go to the number of views, right?
It's kind of group by, right?
It's not group by. So this is basically sorting. So I'm just trying to sort everything based on the rating. See, suppose imagine you have a rating and you have a number of views. So rating is, let's say 5, 4, 3, and number of views is 100, 90, 80, and so on. Now 3 is again coming multiple times, repetitive.
Okay.
Then I don't know how I'm going to order it, because all of them are 3. Any among these 3 can come first, go next, right? Then how I need to know, how I'm going to sort. That is where the second column comes in picture. Now in the second column, it has to be in the ascending order. So it will be something like 90 or 92 or 100 like this. So now it means sorting based on both of these columns in the ascending.
Okay.
Right.
If the previous column value is uniform, then the second will be useful. Okay.
Correct. So the preference will go depending upon how you are writing it. Now, here itself, we can play around with different options. See, now in this case, I'm just simply writing an ascending false, which means both of them carry the descending order, right? So see this example. So what are the columns I'm writing? Column rating and column views. So if you could see, rating gets arranged in the descending order. Everything is 5. Now within the 5, can you see the number of views? They are also been arranged in the descending. 597, 546. And so. So whenever it is duplicated, preference will be shifted to the number of views. Got it? Now, here itself, I can even control in a different way wherein I can write ascending equal to true comma false. Then how do you think it will work? So instead of just simply writing ascending equal to false, I'm saying I'm going to write ascending equal to true comma false. Then how it will work?
I think the first column will take the ascending order, and the
Correct.
next one will be descending.
Yes, exactly. So when you simply specify one, it's going to be based on that one order. You specify all the orders accordingly, it will do the job. So this is mainly used in some of the scenarios wherein we expect a lot of duplicates in a call. So I can control on how the order has to be. Right. And one last thing, which is limiting the data. This you would have seen on your SQL itself. So simple. I can just write limit of 100 and then I can do a show. So that will basically display the top 100 records out for you. I'm not finding a great difference between limit and show, because the show of 100 will also give you the top 100, limit will also give you the 100. So these are just like an alternative functions to you. Okay, so there is no need for you to write explicitly as limit of 100. Rather, you can just write show of 100 itself, and that will do the job for you. Okay, see. So, but
Is
just remember
I
there is
wanted to
a,
ask, is a limit 10 and take the same?
sorry, limit will not take the same.
And when you have you use a take function and limit function or show function, are they all the same, doing the same thing?
Both, that's what I said, both of them are doing the same thing. So when you write just a limit of 100 and then a show, it will give you the top 100 records. Now, if you say, no, I don't want to use a limit, can show itself do the job for me? Very well, it can. Just write the number inside. These are two alternative ways of getting the same output.
What of take?
Sorry, what you said?
Take.
Take will be a function that can be used in your RDDs. If in case you are trying to do it out on a data frame, it will convert that into a file manner. So I wouldn't suggest doing a take, though it can give out the result to you, but see the result.
Oh.
Can you see the format?
Mm.
See how it says. It reports every row the way that how you treat it as a file. So that's why every record it calls it as a row. Now processing them as well as readability is a certain, it's a huge challenge when you're doing a takeoff. But having said that, see, if suppose I'm working on a project, I just want to understand how the structure of the data frame looks like, just to get an idea about it. Very well, you can do a take. But to understand it better, to process it, I would not recommend take. Rather, you can go with a show or a limit.
Okay. Thank you.
Because
Will
take
you share?
functions, collect functions, all these are RDD based. So this is a little advanced topic. I don't want to go deeper, but just understand this thing. See, the moment I'm writing df.take of 10, you are able to view the data just like a row format. But if you zoom in inside and understand what happens, this df will first be converted into an RDD, and from that RDD, it will take the top 10 rows. That is why the output is basically like row format.
Okay, thank you. Do we get to get this file, Python file?
This I already shared. This YouTube file I already shared. This notebook I'll share now. This notebook file I'll upload.
So what about RDD and data frame? So which one we should use?
There is nothing as such, Dakshina. It depends upon the project that you are working with. At any day, data frame has an higher edge because it supports different file formats. It is much more flexible. It is named data. You don't have to worry about their index position. You can control all the columns. So at any day, data frame has a higher end compared to RDD. And nowadays, all the organizations are shifting from RDDs to data frames also. So in that way, I would say data frame is good, but you can use both of them depending upon. See, there are some organization which still works with only RDDs also. So it's not like you cannot use, but slowly there is a shift happening.
Okay. So
Yeah.
actually, internal operation is happening in RDD only, right? Data frame also.
Internally, because that's a bottommost layer of your Spark, right? So
Mm-hmm.
if you remember, as per the architecture, internally, all of them happens on the bottommost layer, which is RDD. But then the integration over here becomes like this through data frames. That's why things looks much more readable for us.
Yeah. In for unstructured data, which
Mm.
one we should prefer actually, RDD or
Uh, in
simply like
unstructured itself, there are multiple types, right?
okay?
Now, if your unstructured is a batch data, right,
Okay.
then Spark SQL itself can handle the log, handle the one. For example, if your unstructured is coming in a JSON format, yes, very well, Spark SQL can handle it, right?
Hmm.
But if your unstructured data is coming to in a streaming format, for example, like it comes from Kafka or it comes
Hmm.
from some other message broadcast service, which comes to you at a speed, then Spark streaming is something that you have to use. Or if it is a textual based unstructured data, like your chat messages, right, or random log files that you want to process.
Hmm.
RDDs can also do the job, data frames can also do the job. But
Hmm.
RDDs are meant for handling such kind of data. So I would prefer RDD for that. Textual unstructured data.
Okay. So what about so actually what's the difference between join and map? We have now some broadcast join and all right, and the map is there.
Broadcast join, I don't think we will cover that here. But then if you are already aware on it, broadcast join is basically like an optimization technique. See, whenever you are trying to join two different data frames or two different RDDs, what actually happens is both of those RDDs will be stored inside the respective slave system so that join can happen between them. Right? Simple.
Okay.
So data frame 1, data frame 2, both of them I want to perform a join. Only when both the data is there inside a single node, shuffling will be reduced.
Please leave her.
Mm-hmm.
Right?
Right.
So
Yeah.
I can do a better job in terms of optimization. But the challenge is the more data you are keeping inside one single slave system, your system will go for a toss. It cannot handle that pressure. It will throw out
Mm-hmm.
an out of memory warning for you, OM error.
Okay.
So to avoid this, what Generative Spark would suggest is, if at all one of the two files is really smaller, now take a copy of that and keep in all the data nodes
Okay.
wherever we have in the RAM space of all those slave nodes, so that there will not be an additional headache of data shuffling. Rather, the small file can be read from the master system and it can be combined with the slave and processed. So processing will be a little faster if you are broadcasting the smaller data frame into all the slave systems.
So okay, what I am doing actually, I am doing like in my local system, standalone. My NES is standalone data only. Okay, standalone process master only. Okay, that is
Okay.
not cluster on. Okay, so in that case, I can
Oh,
use broadcast. No, then
very well you can use.
correct. Okay, okay.
Very well you can use.
Sure, sure. So what about the map and join? So what is the difference between these two actually? Which one we should use? Which
Map
case,
and map and join means I'm not understanding which one you are asking.
like join
Broadcast
also there. No, in normally in Python's pandas. Okay, we have join and map, right? Both.
join and merge you are asking.
Merge, yeah, merge.
Join would be best, but then when it comes to pandas, merge is an best option because the architecture is different between pandas and PySpark, right? In your Spark, join and specifically broadcast join would be the best option for optimization. But if you're talking about uh, standalone Python codes, not in a cluster, just with pandas, then merge would be the best option.
Okay. So what about incremental load? Is possible to do in Parquet? Incremental load?
Parkway files.
Yeah, yeah.
Any kind of files can be incremental load, just that it will not be added on the same file location. Rather, it will be under the same folder. Multiple part files will be created. Not just in
Okay.
Parkway. Any kind of files we can have incremental loads.
Okay. Oh, I can do based on the data also, right? Actually, based on the partition, we can do it, no?
Yeah, yeah.
Please, I've not yet I've not seen the file in the drive, in your own drive.
I haven't uploaded it. Okay.
Okay.
Fine. Any other question, guys? Yes.
Have we covered? Actually, this is actually after some days. Actually, I joined this class. Actually, we can say it's 5 to 6 month gap. Okay,
Okay.
that's external. Yeah. Actually, I have some doubt. Actually, have you explained cloud technology like AWS or Azure? Previous class.
That is not a part on this module. I think there is one more module wherein you will be learning about all the cloud.
Okay.
Not on this module.
Sure. Sure.
So YouTube I have shared. Okay, I have shared the notebook, guys. All the other files I'll share soon. You can take it from there. Okay. I feel you can check on the notebook now. It is uploaded. Fine. Any other questions before we wind up? We do have 2 more hours pending for this particular module, which we will be covering on the next Saturday. And if you have any other,
Can you also give us a few questions for the interview which you feel we should know?
I don't have any dump as such, but then if you can see in my class itself during the time of explanation, I'll tell you these are something that can be asked in interview. So that's how generally I do practice. Probably I'll find if I get to have some mini docs or something I can share. But I don't believe in having it as a separate dump for just as an interview question. Over the period of learning, these topics, whenever I'm saying these can come, you can just make a note of it. Not just as a question and an answer I have. Okay. Yeah. Fine, everyone then. Let's see. Again on next weekend we'll have 2 more hours pending, so I'll be covering the remaining APIs and I'll be also explaining about the pipelining part of how a big data engineering project will go. Meantime, I would also want you guys to come up with any questions that you have extra. We'll discuss about that and we can wind up.
Yeah, Dakshana.
Okay.
I have small doubt actually. We have normally in standalone system, no, we are giving local and local 4, right? For multi-threading purpose, we can give local 4, right? Like
4 is basically because you have 4 cores in that system.
okay.
Yeah. Tell me what's the question?
Yeah, actually, how it will work actually? Can you tell me?
See, in a standalone system, it will always be local because there is no master slave approach there. One system is only the master, that same system is only the slave, right? That is where the keyword of local comes in picture. Inside master, you will just simply write local. And what does that 4 represent is the system on where you are having your Spark running. That is a standalone system, is a 4-core processor system. It
Right,
might
okay.
be 6 or 8 core also, but then for the running of that particular code, you are making use of 4 cores, which means 4 parallel processes can run at the same time.
Okay.
So if you increase the number of cores, suppose imagine you have an 8-core system, but you want only 4 cores parallelly being used for that Spark program, then you can just write local of 4.
Yeah.
Right? So it is up to us. So basically what I'm saying, Spark, is make the best use of the 4 cores parallel. That's it.
That's okay. It'll be fast then, right?
Yeah. Okay.
Actually, I had a small doubt in here. Actually, how that how actually in case I'm giving 4 cores, that the data split will happen. No, like one data will split into 4, right? It will sit in 4 different cores.
Data split need not be necessarily as a core.
Okay.
Data split basically happens depending upon the block size that you are specifying. I might be for having 4 cores, but that does not mean I have to make use of all the 4 cores at the same point of time. What if your data is much lesser such that one core itself can handle it? Why I have to unnecessarily make the parallelism hit there?
Okay. Executor,
Right.
right? Core executor core, right? You can say.
Yeah, so it depends upon the size of the file. Cores is maximum you are giving 4 parallelism to be active at a point of time, but it does not mean always you will use those 4 cores. Depending on the size of the file, depending upon the number of blocks generated, the cores will either be used or not used. Okay. Fine, yeah, we'll connect back again over the next weekend. See you all. Thank you, everyone.